Okay, cool. Nice to meet everyone. I'm Wenbo. I'm currently a assistant professor at UC Santa Barbara, also a research scientist at Meta MSL. Today, I will talk about our recent work, OpenSage, which is a new agent framework where we think could be the future of agentic AI. Before we talk about OpenSage, let's look at the current agent world. How people build agent, right? So basically, the idea is like there's pre-specified agent structure, agent topology, and also tool size, memory structure before you build agent. It's kind of like you build a software, you know exactly what you want to build. You have a clear kind of like system design, and then we build the agent, and then we let the agent run the job. But if we dive in and think about the kind of like limitation of this paradigm, the problem is like if we do pre-specified topology, and also we pre-specify the set of tools that kind of constrain the generalizability of the agent a lot, because reason is we want agent to do complex, long horizon job, but sometimes the agent may spawn its own, sub-agent along the way of execution. Along the way of execution, agent may find out, oh, the set of tools I have is not enough. I need to invent or need to be added for more tools to finish more complex jobs. But if everything is pre-specified, it can constrain the agent capability or generalizability a lot. So that's kind of motivate us to design OpenSage, which we think is what we call Agent 2.0. Pre-hands is like Agent 1.0. So basically, similar as we designed the machine learning models, if we think about it like 10 years ago or even like 20 years ago, when we design machine learning models, the first step we're gonna do is feature engineering. Right, so we need to think about given raw data, what are the features we use, how to extract feature sets from the model, from the raw inputs, and then there are so many feature engineering methods. That's kind of adding our human knowledge, or what we call inductive bias, into the model. But then people found out, we don't need that step. You just train the deep neural network model on the raw data. The model will figure out by itself. And actually, there, without the inductive bias constrain the search space of the model can actually, search for better solutions in a larger kind of search space. So that's kind of here we think about similar. What if we don't build the agent? What if we don't do all those kind of like manual feature engineering, like pre-specified workflow, topology, tool size? What about we just build a minimal set of scaffold that enable the agent to build its own agent, right? For example, we enable some initial tools for the agent, so the agent along the way, agent can spawn its own sub-agent, design its own workflow, topology, write its own tools, or even write its own memories. So that's kind of like the idea behind OpenSage, is to really unleash the power of AI when building agents. Basically, we want something like AI build AI, agent build agent. To do that, sorry, it's not working. Sorry, the clicker is not working. Okay, now it's back. So as you can see, what we want is we want to provide the minimal set of scaffolding that enable agent to build its own agent, including write its own topology, workflow, write its own tools, and also design its own memory. So for the sake of time, I skip the technical detail. Basically, we redesigned the whole, ADK, what we call agent design cookie, to be, that's bad, that's good. To be able to enable the agent to kind of explore its own topology, write its own tools along with the way of execution. So here's a comparison between our OpenSage with Google, OpenAI, all those, frontier agent developer kits on this new capability. As we can say, that's why we call OpenSage, that's Agent 2.0. That's really the kind of like next generation of agent construction framework that enable all these capabilities, freedom, flexibilities that existing, non-existing ADK is able to offer. And then let's look at the performance. So here we're meaning kind of test OpenSage on coding and also cybersecurity related benchmarks. This is our performance compared to Cloud Code and also codex by the time of we release OpenSage. That was about like February this year. As you can see on all this existing benchmark, like notable benchmark like CyberGym, Terminal Bench, 3Bench Pro, and DevOps Gym, OpenSage was able to outperform all existing agent frameworks. This number are a little bit outdated. OpenSage is still evolving. We are also kind of seeing new performance on these benchmarks as well. And another kind of a recent trial we feel very exciting is we actually run OpenSage on the real-world CTF game. For those who know about it, we run it against the DEF CON 2026 qualification game that's kind of considered Olympic in the world of offensive security. It's the most challenging security kind of competition. All there typically require a team of professional hacker working on 48 hours, like even sometimes there's a team with hundreds of hackers work on all these challenges, try to solve them. What we do is like we try OpenSage on 15 of the non-interactive challenges because actually will not be, the organization kind of doesn't allow AI to solve the challenge and submit. So what we do is we run in parallel at the same time the challenge release. So in total, kind of 15 challenges, we're able to solve 7 of them. And after we do a post hoc analysis, 4 of them actually was very close. If we gave, I don't know, another hour, we can solve 4 more challenges. Basically, in total, we were able to retrieve 8 flags and put us on the top 5 in all the teams that ever participated in the game. One statistic I didn't wrote here, also very interesting, is OpenSage was able to beat all the teams that claim they don't use AI or use low AI. Basically, this is the AI-only agent that's able to beat a team of professional hacker that didn't use AI in their competition. So basically, this shows OpenSage was really able to solve real-world challenging tasks because actually all these kind of competitions, all these challenges, when we look at the trace, OpenSage took like 5 or 6 hours of continuous runs, spawn like thousands of sub-agents to solve them. So basically demonstrate OpenSage was really able to scale up its own topology and is able to solve challenging tasks. Now what we are doing is like not only the agent, because we know like building agent is the first step, but the brain, the model itself also very important. Sometimes model need to co-evolve with the agent. This is also kind of motivated by our observation in the sense it's like if we say run OpenSage with the latest model, we found that actually the model haven't fully figured out how to build its own agent. Sometimes model want to spawn new agent, but it actually fail. So this motivates us to bring up this kind of end-to-end or more like holistic framework where we think about we need to build new agents to train the model. We need to basically train the model to better spawn its own agent, better write its own tools. And also we think about the inference stack, like the trajectory of agentic trajectory is actually very different from pure QA task. We also are trying to develop new agent inference frameworks. But overall, what I want to deliver is like we envision the future of AI agents is really, the future of AI agents is really try to open up the freedom to let AI do more explorations in terms of everything that eventually build up to the agent. What we want is to provide meaningful scaffolding, provide a powerful model, provide a more efficient inference framework to make that happen. Okay, thanks.